thing for you guys. Okay, so last notes for this chapter or unit. We've got ionic bonds. Ionic bonds are going to transfer electrons, and typically this happens for between a metal and a non-metal, because we're looking at electronegativity differences. We talked about electronegativities the other day, and we said that the things on this side of the periodic table, why are you not letting me comment here? Oh, because I didn't click this. Things on this side of the periodic table tend to want to give up electrons, okay? So therefore they have low electronegativities. Things on this side of the periodic table, with the exception of the noble gases, tend to gain electrons. They have very high electronegativities. When we have an electronegativity difference of 1.67 or higher, they consider that to be an ionic compound. Okay, now you can end up having compounds that are covalently bonded and have ionic, what they call ionic character. So they have some properties of ionic compounds. And the closer this difference gets to this 1.67, the more likely those covalent compounds will have that ionic character. So when we look at these, hydrogen being the exception, hydrogen can either be a +1 or a -1. It can either lose an electron or gain an electron. So we're going to kind of ignore him a little bit for this discussion. But when we look at these guys, they're going to typically end up losing one electron. Because if they lose one electron, they're going to look like a noble gas. And that's what all these elements are striving for. I know I'm personifying a lot, but if they lose an electron, then what charge will they have? A +1. So this is where the +1 comes in. You asked about how do we know what charge they are. So everything here is going to end up with a +1 charge. Now, we march over to the next column that's headed up by beryllium. And that column then, in order to look like a noble gas, they must lose 2 electrons. If they lose 2 electrons, they have a +2 charge. Okay? March over here. If we're talking about the non-metals, we only have one, which is just your boron. That guy is going to end up sharing, typically. The rest of these, though, are all metals in this column, and typically they will end up losing 3 electrons, which would give them a +3 charge. Now, when we get to the center column here, which is headed up by carbon, most of the time these end up sharing. Okay, and that's the topic of Unit 2. So we're not going to really assign them numbers because usually they're sharing. When we get over here to fluorine, though, these guys, in order to look like a noble gas, have to do what? Gain an... No, I'm in this column here. What do they need to do? Gain 1. If they gain 1 electron, what charge do they have? -1. Okay. If these guys gain 2 electrons to become stable, they're going to have a -2, and these will have a -3. You can also typically look at your formulas. If they give you a formula, oftentimes you can kind of backtrack and figure out what they're going to be. So, for example, if I had this MgCl2 and I didn't know what Mg was, but I knew that chlorine was a -1, okay, -1 times 2 is a -2, -2, which means that this side has to be a +2. I only have one of them, so magnesium has to be a +2. So when you're given metals, those transition metals that you don't know what they are, always start with your non-metal because that's always going to have the same charge every time. And then backtrack from there over to the metal, which can sometimes be a little flaky. Yeah.
Do elements in the D block try and like fill up the D block or lose the D block?
D block gets a little funky, okay? Typically, D block will lose 2 electrons oftentimes to be able to, it gets weird. All I can say is D block is weird. Let's just leave it at that. You can talk to your brother and find out more about that because he's had a lot more chemistry than I have at this point. I'm just going to leave it as it gets weird, okay? But your brother can answer it much better than I can, although he might go completely over your head. So good luck. All right. So like I was saying, if we had copper, for example, so we've got copper. Copper could either be a +1 or a +2. So at that point, you've got to look at your non-metal. So if this is my formula, this guy is a -1, and this is in a 1-to-1 ratio. What does this have to be? A +1. Okay, so always start at your non-metal to be able to get your metal's oxidation number. And when we get into redox reactions, which I believe is unit 4, we do this a lot, this backtracking and going around and everything. All right. I think I got all those answered for the notes. Okay. Any questions about any of this stuff before I go to the I do and we do? Okay. All right. I do. Calcium is going to react with a certain element with a general formula CaX2. What would be the most likely compound formed between sodium and element X? So sodium is a +1. We've got to figure out what X was. Okay. So we're going to start with this. I know that calcium is what? It's a +2 because it's in the alkaline earth metals column. Okay. So calcium is most likely to lose 2 electrons. If it loses 2 electrons, it's going to have a +2 charge. So if this side is +2, this side has to be -2. I have 2 of them. So what is each one charged? -1. So if I go down and apply that to this formula, then it's a -1. So you're going to have this in a 1-to-1 ratio. So which one of these is in a 1-to-1 ratio? Everybody cool with that? All right, we do. Element 117 was recently discovered. They named it tennessine. Assuming that periodic trends follow right a noble gas electron configuration and predict the formula it forms with Mg. Okay, so that is this guy right here, right? We need a noble gas configuration. So what is it likely to do? Is it likely to gain a crap ton of electrons lose a crap ton of electrons, or is it going to just gain 1? Gain 1. Okay. So we know that it's going to form, and I'm getting ahead of myself here, but TS is going to be a -1 charge. And when we combine that with Mg, how many TS's am I going to need to balance out Mg? 2. So that's going to be the formula. I got ahead of myself. We need to do the noble gas electron configuration. So I have to go back to the previous noble gas, which is radon. So this is going to be in brackets Rn. And then I start over here with francium. Francium is 7. What block am I in? S. And I need both electrons. From here, I go numerically down to here. Don't forget about your F block. Okay. So if this was 7, what is this going to be down here? It would be 7 as well. But remember, when we're doing this, what do we have to do with that number? Subtract 2. So it's going to be 5F. And how many things are in that block? That's 14. And then I'm going to pop back up here and grab this row. What is that in my electron configuration? It is period minus
1.
So what am I going to write down? 6D10. And then finally 7P. And it's going to be 1, 2, 3, 4, 5. And there's my noble gas configuration for Tennessean. And I believe that's all I have to do.